Welcome back to this video 4-2 on finding inverse functions from symbolic form. This is the second video, and in this video we are going to focus on quadratic functions. All right, in the first video we talked about linear functions and their inverse, which is a linear function. In this video we are focusing on quadratics. X to the power of 2, right? Second video, power of 2, quadratics. Okay, so again, here are the steps, and before we get to the steps, I want to focus on what type of inverse function. If I have a quadratic, what is the inverse going to be? And I'll go ahead and I'll draw, if I can find my ink. Okay, so here I have x squared. So here's a quadratic function. Now, how do you undo a square raised to a power of 2? Well, you take the square root, right? So to undo it, you take the square root of whatever that value is. Okay, so the inverse of a quadratic is a square root function. Now, in order to make a function specifically for a quadratic, what we have to do is we have to place restrictions on our domain and our range. So when we take the inverse, it is a inverse and it passes that vertical line test like we talked about in the previous lesson. Okay, so we'll go ahead and do that in step 4. So again, just to recap the steps in general, step 1, change the function notation to y. You got to go from f of x or g of x, make it into a multivariable equation. After we've done that, remember, how do I find the inverse? Switch your x and your y, right? That's step 2, switch your x and y. Here's your kind of the main key idea about inverses. Then step 3, you're going to use algebra to solve for the y variable. Okay, and this is important when you use the square root property. So when I take the square root, okay, we are only going to use the principal square root. Now, what the heck does that mean? Well, when I take the square root of, say, for example, 4, I know that this answer is plus or minus 2. Okay. Well, we're only going to take the principal square root, the positive value, and I'll put it in green, positive, okay? This will make an inverse function. All right, so second, or after that, fourth step, determine the restricted domain. This limits the range values to the set of real numbers, okay? So we'll only focus on that specific domain. And then step 5, rewrite the y variable using inverse notation, and we'll write that restricted domain. Okay, so without further ado, here is our first example. We are asked to find the inverse of f of x and state the domain. Okay, step 1. I'm going to go ahead and I'm going to change from function notation to multivariable, right? X's and y's. Now, why am I doing this? That is because step 2, you have to switch your x and your y. X is equal to y minus 4 quantity squared plus 3. All right, now I'm going to go ahead and I'm going to solve. That's step 3. Again, if you forgot, just use order of operations backwards. I'm going to undo the order of operations. So addition, subtraction, I'm going to subtract 3 on both sides. Okay, and we get x minus 3 is equal to y minus 4 quantity squared. All right, now I'm going to undo the square. So I'm going to take the square root, take the square root. We get the square root of x minus 3 is equal to y minus 4. Now, normally, right, when we take the square root here, we would have plus or minus, but we're only going to focus on the positive value. Okay, so square root of x minus 3, and now to isolate y, we will add 4. Now, does the 4 get to go inside the square root? No, it does not. It stays on the outside. I'm not taking the square root of that 4. I'm adding on 4 after the fact. Okay, so do not merge these values. So it's the square root of x minus 3 plus 4 on the outside. This is equal to y. Okay, so which is going to bring me up here to step 4. And step 4 is determining your restricted domain. Okay, so my restricted domain. Now, I do not want imaginary values put out of my function. Okay, so what I'm going to go ahead and do is I need to take my radicand. Okay, and in this case, that's x minus 3 radicand. Okay, and I'm going to set it greater than or equal to 0. If my radicand, the values going inside my square root are less than 0, then I get imaginary outputs, right? The square root of a negative value is an imaginary number. We're not in make-believe land here, okay? Accelerated Math 3, we keep it real, so we're going to get rid of all those negative values. X must be greater than or equal to negative 3. Okay, well, how do I solve this? I'm going to add 3 to both sides, and we get X must be greater than or equal to 3. Okay, so that's my restricted domain. Schwarberg, what about the 4 tacked on the end? I don't care. What about if I'm multiplying by a 2 out here? I don't care. All that matters is the radicand. Whatever is underneath the square root. Some people call it house. What's in the house? Okay, that's all that matters. All right, so there's your restricted domain. And then step 5, we'll write our final response. Here is our inverse function. This function is name's f. So f inverse of x is equal to the square root of x minus 3 plus 4, and then our restricted domain are our x values such that x is greater than or equal to 3. Must be greater than or equal to 3. Okay, there's your answer. All right, second example. X squared minus 2. Okay, so I'll switch to multivariable. Y is equal to x squared minus 2, and then I'll switch my x's and my y's. X is equal to y squared minus 2. Okay, I'll add 2 to both sides. X plus 2 is equal to y squared. Okay, I want to isolate y, so I'm going to take the square root of both sides. X plus 2 is equal to y. All right, so there is my inverse function. I need to make it a function, but first I need to find my restricted domain. Okay, so again, why do we have restricted domain for these types of functions? Well, it has to do with the square root. Okay, your square root function, the radicand, or the quantity that you put inside your square root, must be positive or 0. You can have 0, right? Square root of 0 is 0, but it can't be negative. If it's negative, then you get imaginary values. So I take x plus 2, my radicand. Can you say that? Radicand. Hey, Lonnie. Okay, and you are going to set it greater than or equal to 0. So we solve x must be greater than or equal to negative 2. Cool. What does that mean? Well, it means that our function, named d of x, okay, so is going to be called d inverse of x, which is equal to the square root of x plus 2, and our domain will be x must be greater than or equal to negative 2. Greater than or equal to. All right, so I'm going to go ahead and give you guys a practice problem. Here you go, x plus 5 raised to the power of 2. Please find the inverse, state the domain of the inverse in set notation. I'll pause the video now, and I'll show you the answers in a second. Okay, so hopefully you have found the inverse, and this is what you should have got. Square root of x minus 5, and x must be greater than or equal to 0. Why is it greater than or equal to 0? Well, again, what is your radicand? It's just x. So I set this greater than or equal to 0, and I solve. Hey, I don't have much to do. It just can't be negative. It can be 0. It can be positive. That's cool. Okay, next example. Please go ahead, pause the video, try this example, and then check the answers here. Okay, here are your answers. Did you get it? All right, one more. Here you go. Last example for quadratics. Okay, hopefully you found the answer, and here is the solution. Okay. All right, so that is it for this video on quadratic functions and their inverse, which is a square root, right? The quadratic, that's power of 2. Okay, how do you undo a raised to a power of 2? You take the square root. Okay, now when you have a square root, you have to watch out for imaginary outputs. So when we take a function, we limit, right, our input for that domain. All right, this is the second video. Make sure you watch the third video, which will deal with cubic and cubic root functions. Catch you next time. Be easy, work hard. Peace.